Hi everyone. Let's wait. The numbers are still going up a bit. I'm gonna wait for a few minutes. Well, a few seconds even. All right. Okay. Sure. Maybe we can start. So welcome everyone. Thank you for your participation today to this webinar where we're going to introduce you the concept of the health data analytics and machine learning program. So I'm Marc Chadeau. I'm the director of the course and I created it 8 years ago. And online we also have Sabrina Rodrigues, who's the senior teaching fellow, but I will let her introduce herself.
Hi everyone, I'm Sabrina, as Mark's mentioned. I'm the Senior Teaching Fellow on the course. I also lead two of the modules on the course, and I've also been involved in the development of the course since the beginning.
Thanks, Sabrina. So you have opportunity to ask questions in the chat, and Sabrina will read them out and we'll discuss the answers at the end of the presentation. But first, I would just like to introduce briefly the context of the course, why we developed it, and what's in there, and what's the experience you should expect from the course. So basically, the course was created in 2018 for the first cohort, and that came from the observation that there was a strong disjoint between two communities that should be working more together. One is the medical biological community generating lots of highly informative data sets on one side, and on the other side, the more quantitative research community that was developing interesting, important, efficient models for exploring such data. So our idea was to put together that course as a seminal event, if you want, for creating a community of people working together, where we wanted basically to make sure that the statistical and machine learning developments could find a, a real impactful application in the domain of health sciences. And on the other side, ensuring that people that are developing these models, so people with more of a theoretical background, could actually start thinking of developing models, not per se for theoretical concepts, but to address issues that one might face in health sciences. So the idea is that with this course and with this community that we're trying to build, is to define a common and multidisciplinary scientific culture that would help in analyzing complex data sets for health purposes. So that's really to make the most of methods and of data to help better understanding health and making progress in health sciences. So as such, our audience that we're trying to target and the way we implemented the course is very specific. So we, by construction, are looking for a combination of students with heterogeneous backgrounds. So typically, we've got two main populations that we want to mix in the course. One is strong students with a methodological background. So should that be in statistics, in mathematics, in econometrics, or any quantitative and methodological background, who are willing to move to an applied field, and that field being related to health. And the other part of the population that we're targeting are people with more of an applied or biological background, so typically epidemiologists, medical scientists, biologists, who are willing to go a bit beyond benchmark and superficial models and get the most of data that know a lot. So upskill them in terms of methods. So overall, having these two populations working together in the course with, as you can see, a bit of a focus on applications that helps implementing a collaborative environment, but also a cross-fertilizing culture. So students in the cohort with their differential backgrounds, they kind of nourish themselves and feed each other with their experience, their opinion, and their skills. So that is making a very efficient and uh, transsectional, I would say, environment. And one thing that is really crucial, which comes as a pun on this slide, but is really at the core of our mission, is that we want to train experts and not nerds, in the sense that we want to have people being comfortable with complex algorithm, with more advanced methods, not for the sake of doing something fancy or using a very cutting edge or complicated model, but to address a question. So there's a big chunk of the work, which is to formulate question in a scientific and research-oriented manner, and from this, pick within all the new novel developments, which are the ones that will be the best place to answer the question in a rigorous way. So that's really knowing your methods, not for the sake of knowing the knowing it or knowing the algorithm, but understanding it well enough so that you can make educated guess on what you should be using for addressing this or that question. And also, at the core of our course is that development of methodological of research questions from real data is also an important aspect of the training. So these are the key numbers that we've seen since the first cohort in 2018. So as you can see, we started with 18 students, and last year's student, we approached 60 students. So what you can see from these numbers is that this is a very, very selective course, and very there's quite a bit of a competition. So for instance, last year we received more than 700 applications, of which a bit more than 400 were eligible, which resulted in less than, well, 90 offers made and 60 students enrolled. What was the key element for all these cohorts, which we're quite proud of, is that for each of them we had a very nice diversity of profiles, of age, of country of origin. So that was a really nice multicultural and multidisciplinary cohort that we created along the years. By the way, quite a few of the teachers that you will encounter during the year are former students of the course. So this year, well, the ongoing year, we had over 750 application, a bit less than 400 eligible ones. We made 80-ish offers, and we ended up with a bit more than 50 students enrolled. Of the students enrolled, we had a majority of women, so we're quite happy with this. We had a large number of countries represented from Europe, Middle East, Asia, Africa, the Americas, USA. So a very, very global population, I would say, with a very diverse and complementary set of skills, including math stats, some engineers, some people with a background in human sciences, of course, people with epidemiological background, molecular biology, pharmacy, medical students, biomed students. So a very nice diversity of profiles, which is contributing, as I was saying before, to the cross-fertilizing environment that you will be involved in. Also of note, there is a large range of experiences and of expertise in the cohort. We have students that are coming straight away from BScs, but we also have professionals in the middle of their professional career switch and so on. So we do have people with different ages, different appetites, and different levels of expertise, and that's also contributing to the multicultural and enriching environment that we're creating within the court. Of note, we're doing a lot of social events, and we're really keen with Sabrina and with the team to create like a cohort spirit. There's an alumni structure, and we're also along the year organizing quite a few social events to make sure that there is a kind of a cohort spirit and a cohort culture that emerges within a year. So now more on the teaching itself. How does it work? We do have three main terms. The first two terms are taught terms, and the third term is relating to your individual research project. So this is how term one, which starts in October and finishes just before Christmas, this is how it looked this year. So you have 4.5 to 5 days of module teaching per week. You have some time reserved for independent work and study. And you also have some additional resources on these 3 days, including practicals, additional tutorials, seminars, and student presentation. So in the first term, you have a combination of five main modules. So you have two cousin modules called Introduction to Statistical Thinking and Data Analysis, led by Dr. Zuber and Dr. Muller, who are key statisticians in the department. And the idea here is for you to get an understanding of the statistical concept that we need for epidemiology. So that module will probably look like a rehearsal or something that you've already seen for students with a more methodological background, but you will see it with a different angle, which is that of health data science. And that would be more of a novel module for students with a more applied background. Corollary, you have the other one, which is on the principle and methods of epi, which are led by Dr. Philippos Philippidis and Amanda Cross, Professor Cross. And so in this one, you will be introduced to the main methods, the main study designs, and the key concepts of epidemiology. And again, for this one, people with more of an applied background, this will be more of a rehearsal or a refresher and might be a bit more novel for students with a quantitative background. So those two modules, if you want, are complementary and are, as this is how we see it, a way for our heterogeneous population to share the same language and the same concepts. So that's also contributing to the gluing, if you want, of the cohort. And then you have three other modules which are specific to the course and that are clinical data management, led by Dr. Cheng and Mr. Thomas Wright. And so the idea here is that you get introduced to database design, query, maintenance, and the strong legal security and ethical constraints that you may have when you're dealing with human data and health data. So that's a very important module that will teach you a lot of the important know-hows when you're analyzing real health data. Then you have another module called Molecular Epidemiology, led by Professor Degen, where you will be introduced to multiple omics data. So omics data are molecular data that are getting more and more popular and which are very, very important tools. So we are introducing them in term one because they represent a very, very important field of application for us, and it represents an extremely complex and challenging setup where you have huge data sets, like with up to millions of measurements in up to hundreds of thousands of individual. So in that module, you will get an overview of the different omics data that are available in the real life and how they're relevant for health data science. And finally, you have a fifth module, which is actually split into two terms called translational data science that Sabrina is leading in conjunction with Lisa Semenova. And in that first half of the module, which will happen every other week, you are introduced to the practical aspect of health data analytics and making sure you are able to conduct research in a rigorous, transparent, and reproducible way, which are key elements for making good science. And all these concepts are going to be taken forward in the second term, where you will have actual research projects to conduct. So this is how the term two looks like. We call it more of the specialty term, where you have four different, no, actually five different modules. No, four, sorry, different modules. So you have three cousin module called AI for Health Science, led by Lisa Semenova, where you're going to be introduced to principle of AI, what are the main algorithms that you can see in the literature and that you can implement yourself, how you would implement them, how you would fine-tune them, and importantly, how you would interpret the result, interpret and critically appraise the results they produce. In parallel, you have a module focusing more on machine learning, led by Dr. Vukovic, where you're introduced again to the main methods that you have in machine learning, how the models are estimated, and how you interpret the results. And the third core module for this term is led by myself, called computational epidemiology. And the idea here is, again, to go more on the statistical side to understand what are the main methods to analyze and integrate complex data sets. So these three modules will take you uh, through quite a few methods. Some of them are similar and overlapping, but they're viewed in a different angle. For instance, some for machine learning are more on prediction, while in computational epi it's more from the etiological and mechanism point of view. So you will have an overview of a very large amount of methods, and our key emphasis in all these three modules is to make sure that first you have a very detailed understanding of the calculation underlying algorithms and assumptions so that you can make an educated guess on whether or not that method is applicable and is valid for that specific type of questions. And also an emphasis on the real world application. You will have access to data sets on which you're going to apply these approaches on real data, and to make sure that you can interpret correctly and critically the results they produce. All of these methods are going to be immediately translated into the translational data science module part two. So that's the second part of the module, where this time you're not going to look at the coding and so on as you had in term one, but you're going to use these know-how and these computational ethics that you've taught in term one to actually analyze a real data set. So you will be given a real data set at the beginning of term two, and you will be asked to use models from the three core modules, AI, machine learning, and computational epidemiology. Use these models to address your research question of interest. And doing so with the quality standards that you have been taught in term one. So as I mentioned, there's quite a bit of project work and real work application throughout the course. So you have some nano project, I would say, within modules where you in groups you can work on some toy example data sets, which are usually real data sets. You're supervised by the tutor that can help you during the practical sessions to make sure that you apply the data, the models in the right way, and that you're getting guided into that implementation step. And this is evaluated through presentation and orals. You have the big translational research project, which I just referred to, where this is a group work on a real data set with, again, a real research question that has not yet been addressed. So that's really putting you in the shoes of an actual researcher with a question that we have, which is scientifically valid and that has not been addressed yet. So you're going to use the data you've been given access to and the method that you've learned to address them. This will be supervised by us and by tutors and module contributors. That will be evaluated again by a report and a short presentation. And finally, in term three, you've got the individual research project, which is in that case a real data set with a real research question that will be supervised either internally or externally by the data expert. You're going to be doing that alone, so that's an individual research project. And you've got in September a report to be handed over, and you also have an oral viva for assessment. Modules. So in TDS, we give you the project. So it's usually a real data set that we have access to in the school, and you work on them. And there's a 3 or 4, depending on the cohort size, project that you work on in groups. The individual research project. So we provide a list. So last year we had, it was not 70, it was actually more closer to 100 projects available for our cohort. Again, all of them were real and unexplored data set with a question of interest. And the idea was that you would be supervised by the project proposer, and if needed, someone from the team, knowing that these projects can arise from external sources. We do have collaborators in other universities, in other departments that sends us projects. You can also have projects that are done in conjunction with the industrial partners, and you can also come up with your own project. So the idea is that if you know what you want to work on, or if you know with whom you want to work with, then you tell us, and then we try to set up a project that would tick the box of your learning objectives and make sure that you can have that as your summer project. I'm not going to list it because this evolves from one year to the other, but what I'm trying to say here is that there's loads of diversity in the type of project that could be proposed. Um, Typical people with whom we're working to get project are the pharma, we've got some finance, we've got some startups, we've got some quite a few diversity of people. And then in terms of research project with academia, we have project with more of an epidemiological um, major, some with more of a machine learning or a methodological. So you've got a very rich diversities of projects available. During the course, there's also quite a few additional resources that are offered. So you do have optional teaching. So for instance, because we're dealing with a heterogeneous population of students to start with, we do have optional teaching, some on mathematical refreshers, for instance. So you have a 3 session on linear algebra, which could be useful, well, even for the methodological students, but definitely for those with more of a applied background. Similarly, we do have an introduction or a refresher if you want on molecular and cellular biology, and we do have sessions on Python programming. We also have some in R this year, which I haven't listed here. But basically, these optional teaching is to make sure that everyone's level is comparable and it can all work together and understand the same things. There's also a series of seminars that are very important and very enriching. So, for instance, some on Bayesian modeling. And importantly, you also have access to quite a few keynotes, which are provided by experts in health data analytics who are invited for a guest lecture. And this is usually a fantastic opportunity for you to get to know these people, to understand how what you're learning in the course is useful in real life research. And importantly, it's also a good opportunity for you to get access to people that are very difficult to grasp usually, and you can. It's a nice networking opportunity. And I would like to finish with just highlighting some links in case you need some financial support for applying. So there are some scholarships and some application fee waivers available. So here are the links. And the idea here is that we, as much as we can, we want that the financial situation should not be a limiting factor for you to join us. So if you foresee an issue, you can contact us and we can try and find a solution. That's it for the presentation. So now maybe we can run through questions, Sabrina.
Sure, there are a few. So we'll start with the first one. Are there patterns in ineligible applications? That is, why are there so many ineligible applications made?
Well, yeah, well there are some. Well, the eligible applications are you have some degree classification and so on, so that needs to be fulfilled, which is well documented on the page. And the moment you tick all these boxes, then those applications become eligible, and then we review them.
Okay, next question. Are we going to build some projects throughout the course to build our GitHub potentially for future employers? Or are there any kind of workshops addressing building projects?
Well, you work on GitHub. Well, Sabrina can tell you more because she's in charge of doing this. But yes, of course, all the project work is taught in with industrials and academic standards, high standards, making sure that you can share your code, that you can review your code, that you can version your code properly. And so that's all embedded. So we're using GitHub. But yes, absolutely, you will have a lot of exposure to GitHub. and your Git will be yours, and you will have the codes that you have developed during the course.
Yeah, so just to expand on that, so taking into account feedback from students from the previous cohorts, so this year we've had three specific sessions on GitHub.
Well, there
Um,
was one today, actually.
yes, there was one today. There was one within the AI for Health Sciences module, and there was one at the beginning of term one. And then within the translational data science project, you also work using a GitHub repository in your group. So we really emphasize that because there is a sort of a little bit of a learning curve with GitHub. So we're just really trying to give you as much practice as possible on that front. Okay, so next question. I have a background in programming. I'm curious, does this course dive deep into ML, mathematical foundations of machine learning, or is it more focused on introductory concepts and basics?
No, it goes beyond introductory concepts. You see quite a few algorithm. You dive into the difference in the algorithmic composition of the models. So you get far, far beyond just introducing the concept. But it is not a course on the mathematical proofing of all the behaviors of the models. But you are, I think the answer is that you're in the middle. It's nothing like introduction. It goes far beyond that. But it's not a methodological course in the sense that it's not about proofing the behaviors, proofing the conversions, and so on and so forth. So it's an applied methodological angle that we're taking from this.
Great. The next question is from Christina. Are there any modules in term two that apply AI to image analysis? For example,
Yes,
for biomarker detection.
we do some image analysis, but not only image analysis, but yes, in the AI module and in the ML module, there is quite a bit of segmentation algorithms and image analysis included. Yes.
Next question is the technical side of the course sufficient for graduates to move on to data scientist roles in non-medical fields? And if so, what are some of the non-medical companies alumni have worked for?
Yes, so it is a very popular course also for employers. I mean, our students are very employable in many different academic themes and many different industries, including finance, including pharma, including, well, there's an exhaustive list, so I can't tell you all of them. I think the value that and the skills that employers like about our students is first their technical knowledge and their critical thinking, because uh, this is what we teach you is to be creative in using different approaches, sometimes outside of the scope that were developed for, but do that with a your critical mind hat on and making sure that when you're doing this, you know what you're doing, you know what are the pros, the cons, what are the limitation in the interpretation, and so on and so forth. So this is actually beyond the technical skills, what the employers like about our students.
Okay, so the next question is about understanding how much knowledge in coding languages do they need to have before starting the course, and is Stata basic enough, or do they need to learn R?
No, there's no prerequisites. The course is self-sufficient, and we make sure that you're taught exactly what you need in terms of programming. So some students prefer to come prepared. So the main language that we're going to use is R for most of the modules, but there's also some work on Python, some SQL also being taught, and so on. But again, there is some optional teaching, some refreshers that are organized early in the course to make sure that everyone knows what they should be knowing. So there's no pre-course level required.
Yeah, and so just to add to that, so for those students who have accepted a place on the course, we do send out some material that they might want to look over before starting the course, but it's not mandatory. And a lot of this material covers some initial coding skills that you can obtain in R mostly. So a lot of the students find that helpful, but again, it's not mandatory. So the next question is, what is the ratio of teaching hours to independent study? Are there full days of teaching lectures, or is it just a few hours per day with the expectation of independent study alongside?
So yes, so a typical day is 2 to 3 hours lecture in the morning and 3 to 4 hours practicals in the afternoon. Sometimes it's a bit shorter, sometimes it's a bit, well, it's never longer than 4 hours. And then you're expected, yeah. But you have some days where you have independent study time, so for the full day. So it's usually on Wednesdays. And during these times, you're expected to have your independent study, and you can also do that in when you don't have deep practicals.
Um, Next question is, would the course be suitable for doctors approaching end of training in terms of mathematical based knowledge needed?
Yeah, yeah. Well, we have a lot of medical students coming to the course and successfully completing it and bringing their knowledge back to their clinical practice later on.
Okay, so how suited is the program for less epidemiologically focused research in medical sciences like AI modeling in ECGs or omics modeling?
Sorry, I'm not sure what the question is.
So how suited is the program for less epidemiological
Ah,
focused research in medical sciences? So involving AI modeling in ECGs or omics modeling. That's very
well,
suitable.
it is. Yeah, yeah, it
Yeah.
is. It is it is the course you need.
Yes. So there's a lot of research done in multi-omics modeling. So Mark can talk to that, obviously, because that's what Mark does most of his research on. And AI modeling. I'm not sure what ECGs are.
I know it's the electrocardiograms.
Oh, ECGs, right. Yes, yes. So we've had
Yeah, yeah.
several
There's a
research
lot of
projects.
projects on the EHRs and so on. So
Yeah.
yeah, well, I call that epidemiology because I'm biased, but yes, definitely these fields are very very valid for well the training that you get is going to be very valid for these fields.
Next question is more about the application. So where would the best place in the application be to portray personal data science projects?
Sorry,
So
the line is not. I lost it. I don't know.
Nandita is asking where would the best place be to portray in her application personal data science projects? In what section of the application?
Well, in the covering letter, I guess,
Okay.
and you can
Okay.
highlight it like in bullet points in your experience in your CV.
Our next question is from Siddiq. Um, I want to ask, how will the course help us cover concepts related to biostats and programming since we are purely from life sciences background? Do we have additional courses for students from medical applied science background?
Well, as I said, there's the optional and additional trainings that are organized in term one. And we also organize along the way during the year. If we see that something has not been taught properly or there's some question pending in the court, we will also organize sometimes some additional sessions to clarify some points relating to very specific elements of the teaching. But usually we don't have to organize many of those because things are getting sorted usually. But we do what 2 or 3 a year, and again, uh, most of this is taken care of by these optional training and teaching that you have in term one.
And for the programming as well, we give you access to data camp. So on data camp, there are um, many sort of short courses on particular programming languages, so you can also practice on those. Um, is it possible to show an example of a week timetable? So I think in the slides, Mark has essentially
Yeah,
showed
I
that
can share it again.
beforehand.
I can share it again. 1 second.
Unless the specific student is asked after sort of hours and so on, which we don't have in the slides.
No, but I can, well, yeah, there you go. Can you see my screen again?
No,
No?
no,
Now?
yes.
All right. So that is the term one schedule. So on Monday, you have in the morning, every Monday from basically 10 to 12, you have a lecture, a session, a series of lectures, usually two lectures in the morning. Then you've got an hour and something break, and then you've got 2 to 3 hours practical in the afternoon. Same goes for Tuesdays, we've got the same for epidemiology. Then you have every other week TDS, as we discussed. And in the other weeks where you don't have TDS, you do have those optional teaching that I was referring to. So biomedical science, so that's the introduction to omics and so on. You've got Python programming. So these are usually 2 to 3 hour sessions with some tutorials and some exercise. You do have Python, you do have linear algebra, and what we are going to also introduce is some R teaching as well. Then you have the same structure for clinical data management, where you've got 2 to 3 hours in the morning, 3 hours in the afternoon practicals, and same goes for molecular epi. Yeah, and in the second term, you've got less free time. You do have, however, some of the Wednesdays that are free. What I forgot to mention is that we also organize a reading week. We're going to try and organize another one for term one next year, but we can't guarantee we can. Where you basically can reflect on what you've seen in the first half of the term and make some revisions and get ready for the second half of the term. I hope I answer your question.
Okay, I think that might cover that. Then the next question is, are there opportunities to participate in on-campus research labs?
What would be research labs then?
Uh, I don't know. It's an anonymous question, but so potentially in our situation, it would be coming to experience sitting with the team in the research, or this happens a lot in the summer term. So in term three, where you can go and work with your project supervisors, and sit in their sort of pod. We don't have sort of research, a physical sort of research lab. We've got these pods where research groups tend to
Oh,
sit.
sorry. Yeah. Okay. Yeah. Yeah. Sorry. I didn't understand. Yes. So you'll be exposed to this, but basically you're in our building. We're like 3 floors above in our offices, and so you're meeting the community every day, pretty much. And the course is extremely research oriented. I mean, what we teach is what we do as a researcher. So you'll be really in the middle of what we do.
The next question is from Yike. So are there opportunities to have access to deeper extra teaching materials in domains such as ML?
Well,
Hmm.
the teaching materials that you will have access to are already quite deep, but there are some additional teaching resources within each of the modules. So that sometimes includes some data cam stuff, some MOOCs, some external resources. So yes, you do have it, but again, the course itself is already intense.
Yeah, and just to add to that, so for each of the modules, each module will have a list of um, sort of supplemental reading, which we recommend, and optional reading. So in that optional reading list, there's a lot of materials that have been identified by the module leads for students to read up on further. if they're interested in. And generally, that's where more advanced material is also placed. Right. So the next question is, what is the difference between this course and health data science by Maxwell? Is not sure which course this health data science course is. Is it the Imperial one? Um, is it another?
I'm not sure which course you're referring to.
Yeah.
The only
If you
thing I can tell
can
you
maybe.
that we were the first one to create the course with that angle of applied but still uh, methodological. Well, basically the first one in house data analytics in London and in the UK, I think. So,
Okay, so we've got a few more questions. So with AI developing so quickly, how does the program keep up with new innovations? I'm interested in how the curriculum adapts to include the latest modules.
well, we change the content of the modules every year. And we, again, as we are active research in the field, we adapt the content to make sure that what you learn is what is actually used in the world. So from one year to the other, the content changes and adapts to the latest development.
Right, so this question is from Yuhao. Will there also be materials provided to students coming from a more quantitative background regarding preparations to courses such as molecular epidemiology during the summer break? So I can answer this one. So as I mentioned before, for those students who have accepted an offer, um, a few weeks before induction week, we send out some material. So essentially, it's a link to a page that we've prepared beforehand to an online page. And on that page, there is a section dedicated to upskilling your programming skills in R, and there is also a lot of content when it comes to stats. And there is some content related to molecular epidemiology. So, what I can do is I can just double check if there is enough material there and add some additional material for those interested students.
But again, these are optional.
Yeah.
It's usually students feel more comfortable doing it, but it's not needed.
The next question is, how much exposure do students get to working with real-world clinical data sets such as electronic health records during the taught modules?
EHR, you've got a few practicals on EHRs. You have also quite a few practicals on UK Biobank like data sets. You do have access to real studies that are publicly available that we actually generated. So you've got EHR per se, you've got quite a few, you've got several specific sessions on that. And then you also have access to other large data sets with individual based data. But there's not much, I mean, in terms of algorithmic phenotyping and so on, that's not part of the curriculum, but some students were exposed to that during their research project. And the methods that were used were those that we taught during the terms. So that's something
Yes,
of interest. You can do that through the research project.
and there tends to be quite a few of these research projects involving electronic health records as well. So next question, you mentioned the course goes beyond the basics. For someone with programming experience, could you share examples of the topics or projects that would let us build on that experience?
Oh, these are tough questions. Examples of what? Of how we go beyond the basics.
Yes, in for someone who has programming experience. Well, I guess it will depend on their programming experience, but there are after examples of the topics or projects that would let us build on that programming experience.
Well, basically, it's I don't know. We it's a difficult question to answer, but it happens that so typically on the TDS this year we have students working on a specific disease, so they can either the basic would be just to run every model they've learned in all the classes with the common implementation and so on. But what we ask them to do is to go beyond that, to fine-tune the model, to make sure they adhere, like, for instance, applying some sensitivity analysis or doing some subsampling to assess stability of the results, these kind of measures that are going far beyond just using as a black box tools that just learn. So what we ask them is to usually reparameterize the model, sometimes embed them into subsampling, doing quite a few sensitivity analysis, and have a strong reflection on the stability of the results, of their interpretability and their reproducibility. So this is where we go far beyond just clicking on a button or implementing a pipeline. This is bespoke analysis of precise data.
Yes, and so with respect to the programming component, so with the translational data science project, we really focus on enabling students to run multiple analysis at the same time using the high performance computing cluster. So where the students learn about parallelization on their computer, but also on the server. So that really then that will help you boost your programming experience further. So just it goes beyond you just knowing how to program in R and in Python, but it also will give you skills to program in Bash, which will then allow you to interact with most servers worldwide, and also run analysis at scale on those servers. Mhm. And you also, as a master student, postgraduate student, have access to the research computing team who also have additional courses. So they run a year, different courses throughout the year covering different aspects of programming if that's something that you're interested in. It's really about finding the time in your schedule to attend those additional courses. Um, so does it impact students' prospects for data science jobs, as those keywords aren't in the course title, even though the content clearly reflects a data science skill set?
Well, again, as I said, our students are very employable in many different ways, so I don't think it's,
Mhm.
yeah, I don't think it's an issue.
With the multidisciplinary focus of the course, is there work research done with other departments at the university?
Yes, and other departments and also other universities.
Mm. Okay, so I think the next comment is related to the
Oh yeah.
question around how is this course different to a health data science course at UCL or different universities?
The one I know at UCL, for instance, I was part of their board. It's more about bioinformatics and data wrangling. Here we're really capturing this, but also data analytics. And so it's also about making inference from these big data sets and not only curating the data. So it's including data wrangling, but also analyzing with a wealth of methodologies and an emphasis on careful interpretation. So basically, what you learn to do in our program that I don't think you learn that much in the others is really get the full picture of the research mind to analyze data. So from question generation to paper writing, as in critical appraisal of the results that you generated and formulating the next steps of the analysis.
Okay, so two more questions. So I'm a medical registrar with 1 year left to be consultant. I haven't worked with data or statistics before. Would it be challenging to keep up with the course content?
Uh,
Mm.
in principle, no. I mean, we've had students exactly in your situation who had no problem in doing the course. It requires work. It's going to be a lot of work, but no, it's not a problem, and you should not feel shy about applying.
Right, okay. I think those are all of the questions. There doesn't seem to be any more questions.
All right. In that case, thank you everyone for your attendance. I hope this session helped. And a piece of advice is that this year in particular, the course is extremely competitive. So if you're interested, the sooner you apply, the better. All right.